right, let's look at some derivative and tangent problems that are solved with limits. And so when you're using limits to answer these kinds of questions, you have to decide which of the two limits do you want to use. And these are the two limits that were um, introduced in that video that you were supposed to watch Thursday night before I dropped off the face of the earth. And so let's look at question number 1 here. It says, find the slope of the line tangent to f of x at x equals 2. That whole sentence could have been really shortened to just find f prime of 2 if f of x equals this. So it could have been shortened a little bit, but that's all we're doing is we're finding f prime of 2. And I could use either one of these two methods. And if the choice is up to me, I have always found that if you have the point of tangency, the x approaches a method is a little bit easier. If you're looking for the general derivative, the h approaches 0 method is a little bit easier. So for me, f prime of 2 is going to be the limit as x approaches 2 of f of x minus f of 2 over x minus 2. And after that step, it's really just a bunch of plugging in and doing a little bit of arithmetic here. I will need f of 2 first. So that's 3 times 2 squared is 12. And that ends up giving you a value of 3. So let's plug that in. And I'll also replace the f of x with the equation that is f of x. So we have 3x squared minus 5x plus 1 minus f of 2, which was 3, all over x minus 2. And now we clean this up. I'm going to subtract 1 and minus 3 to get negative 2. Now we're going to factor and cancel. So 3x squared. Let's see. We'll take advantage of the fact that this is a limit and it's a tangent problem. And if you want to plug in, that's always a good first step. When I plug in x equals 2, you will get 0 divided by 0. And you always will in these limit derivative problems. So if you don't get 0 over 0, you know you've messed up. Since I do have 0 over 0, that means I know something cancels, and I'm going to take advantage of that knowledge to go ahead and put an x minus 2 up here, and then I'll figure that 3x times x is x squared, plus 1 times negative 2 will give me that negative 2. Double check, I do get the negative 5x. Cancel the x minus 2's. Plug in 2 for x, and we get 3 times 2 plus 1, or 7. So there is f prime of 2, the slope of the tangent to that function at x equals 2. Okay, so let's find the equation of the line tangent. So if you're finding the equation of a line, regardless of what kind of line it is and in what context, every single time in your life you've ever found the equation of a line, you will always need any point and the slope. Some people want to say slope and y-intercept, which will work if you happen to have the y-intercept, but you don't have to have that specific point on the curve. It does not have to be the one on the y-axis. It could be any point, because if you have any point, we'll call it x1, y1, and you have the slope, there is a beautiful linear equation called point-slope form that is absolutely acceptable. It's y minus your y-coordinate is slope times x minus your x-coordinate. And you can leave it exactly like that. You don't have to distribute the m. You don't have to solve for y. It does not have to be in slope-intercept form. This is an acceptable answer. And so I need a point and a slope. So my point is going to be f of 7. That'll be the square root of 7 minus 3, which is 4. My slope, however, is going to be a lot more complicated. I'm going to have to start that over here, because my slope is going to be f prime of 7, which I will set up as that limit. X approaches 7, f of x minus f of 7 over x minus 7. And as long as we are new to these limits, I strongly recommend that you actually write that generic form down, because the more you write that, the more likely you are to remember it. Once you are comfortable with it, then maybe go straight to substituting the f of x and the f of 7. But until you have this really committed to memory, I would recommend writing that every time. Now I'm going to substitute, and then after I substitute to get this set up, I'm going to pause the recording and work this out to show you my final slope. F of 7 was 4 over x minus 7. So there's the setup. Now what we have left to do is solve this by I'll use conjugates. So give me a minute to do that, and we'll see if you can get the same thing. Okay, and I just caught a mistake. So just show you some things to look for. Um, I'm not in the clearest space in my mind right now. The square root of 7 minus 3 would be the square root of 4, which should be 2, not 4. And the reason I caught my mistake is because I knew that I should have something cancel. And when I used my conjugates, I ended up having x minus 19 in the numerator because that should have been a 2 instead of a 4. So let me fix that and see if this clears up just fine. So plus 2. Now I'll be x minus 3 minus 4. Nope, minus, yeah, 4 is correct. Over x minus 7 times square root x minus 3 plus 2. And if you look in the numerator, x minus 3 minus 4 is x minus 7. That x minus 7 will cancel this x minus 7, and we can plug in 1 over square root of 4, which is 2, plus 2 is 4. So there's my slope, my point. When I plugged in 7, I got the ordered pair 7, 2. So I'm going to take this piece. Actually, I shouldn't box that because it makes it look like the answer. I'm going to take that, and I'm going to take that, and we'll take both of those and just roll this into point slope form. Y minus 2 is 1/4 x minus 7, and hopefully that's right. I feel like it is. Okay. The derivative of the function. This time I just want the generic f prime of x. I do not want to plug in a point for x. And for these problems, I really think that the limit as h approaches 0 is the easier one. Now, I know the formula I gave you at the very beginning of this video said f prime of a is f of a plus h minus f of a. I'm just going to use x instead. I would rather use x's for my general derivative. And so let's go over here and figure out what f of x plus h would be. That would be negative 3 x plus h squared plus 7 x plus h. And then it's just a little bit of algebra here. X squared plus 2xh plus h squared. Distribute my 7 plus 7x plus 7h. There's an h over there. You can barely see it. Negative 3x squared minus 6xh minus 3h squared plus 7x plus 7h. All right. And then finally, that's the worst part of these problems. I'm going to take this and I'm going to put it in the place of f of x plus h. I will take the original f of x, put it in the place of f of x here, and then we should get some things canceling out. So f of x plus h is negative 3x squared minus 6xh minus 3h squared plus 7x plus 7h minus the quantity of negative 3x squared plus 7x. And for the sake of time, I'm going to be a little bit lazy here. I'm going to distribute my negative here. This is going to become plus 3x squared minus 7x. And at this point, every single term in your numerator that does not have an h should have an opposite that subtracts it out. So I see a negative 3x squared. There's no h in that. Here's a positive 3x squared. They zero each other out. 6xh, nothing combines with that. 3h squared, 7x, no h there. So that positive 7x should have a negative 7x, and we do. And then we have the 7h. And then once you are done, once you've canceled everything without an h, every other remaining term has an h in it. We will factor that h out, cancel it with the h on bottom, plug in 0, and we'll be done. And now be careful when you cancel because I almost scratched that negative out and I'm seeing it. But it's easy to lose signs when you get carried away canceling things. Now I can cancel the h on top and bottom. And one common mistake on these is people may plug in for the wrong variable. Notice this is the limit as h approaches 0, not as x approaches 0. So we'll have negative 6x plus minus 3 times 0, so negative 6x. I'll be plus 7 in the end, and that is your derivative, f prime of x. And then the last type of problem we're going to look at These are very, very quick once you get the hang of them. In these problems, the last 6, I want you to unpack the limit and find the original question. So the very first problem we did, number 1, I gave you the function. Here's a function. I told you the point to find the tangent, and we used that information to create this limit. Here we're going in the exact opposite direction. I'm giving you the limit. I want you to tell me what is the point and the function for the tangent line. And so first thing we have to do is decide, are we looking at the limit as x approaches a or h approaches 0? And this one, x is approaching 16, so we are very clearly looking at this one right here. And these are the easier ones because f of x is explicitly in the limit. And for this one, that's going to be the square root of 16. And a is also clearly in the limit because x is approaching a. So a would be 16. I have another typo right there. This should be f of x is the square root of x, not the square root of 16. And that is all I want you to do on these problems. The h approaches 0 ones are a little bit trickier. I'm going to leave that for you to figure out. But there's an explanation for number 8, and you're only writing down f of x equals something, a equals something, and go with that.